We have one more example to take a look at, and it is continuing with this idea of when I have an extra power, how do we handle this? There are three factors here. There's x squared plus 1 squared. So there's two of those x squared plus 1s, meaning I have three factors. So when I set up the partial fraction decomposition, I'm going to have three fractions. The first one has a denominator of x. The next one has a denominator of x squared plus 1, and then we build those powers and have an x squared plus 1 squared. Deciding what to put above is looking at what are those base factors. Here we have a linear, so above a linear, we put a constant, just a. Here we have a quadratic, so we put bx plus c. We put a linear above the quadratic. We can't factor x squared plus 1 anymore. So it's going to remain x squared plus 1. And then we generally, for the last one, we ignore this squared. We need the squared to appropriately set up the partial fraction. But when we decide what to put above it, we're going to ignore the square and look at the fact we have a quadratic. We have x squared plus 1. Since we have a quadratic, we put a quadratic above. Sorry, a linear above. So dx plus e. If you're ever wondering, do I have the right number of unknown coefficients? If the number of unknown coefficients, your ABCs, is going to match the degree of the denominator. So the degree of the denominator, in this case, we have, if we multiplied this all out, our largest power would be x to the 5th. So it would be a 5th degree polynomial. We have 5 unknown coefficients. You can go back and look at the previous examples and see that logic lines up on all the others as well. So we have 5 unknown coefficients to solve for. That is a lot, but we will see this work out really quickly with some multiplying. So multiplying by our common denominator to clear our fractions, we get x to the 4th plus 1, because the common denominator clears everything on the left-hand side. And then when I multiply a over x by this denominator, the x's will cancel, and I'm left with x squared plus 1 squared. When I multiply bx plus c by the common denominator, don't forget parentheses, one of the x squared plus 1s will cancel, but we'll be left with an x and an additional x squared plus 1, but only one of them. And the last part, dx plus e, in parentheses, when we multiply by our denominator, we have the x squared plus 1 squared, but we do not have the x. So just an x on that last part. Gonna multiply this all out. I'm gonna do it in one step, but you may need to, when doing these problems alone, be careful about multiplying everything out properly. But x squared plus 1 squared is x to the 4th plus 2x squared plus 1. Bx plus c times x squared plus 1 will become bx to the 4th plus bx squared plus cx cubed plus cx. And then dx plus e multiplied by ex is dx squared plus ex. The nice values method here would be very long and tedious because we actually have 4 coefficients that don't have nice values that will make them easy to solve for. We can get A really quickly, but we can't get B, C, D, or E super quickly. However, if we do a little bit of that coefficient grouping, these will solve pretty quickly. So doing the coefficient grouping, we want our constants. On the left-hand side, we have a 1 for the constant. And going through the line, we have A is constant. Everything else has an X on it. So we actually know 1 equals A. And I said that was the one that was going to be really easy to find. We've already found it. Now, taking our X's together, there are no single linear X's on this other side. We have a quartic and we have a constant, but we don't have an X to the first. So the left-hand side is 0. And gathering the linears, the ones with an X to the first, going down the line, we have a C and we have an E. So C plus E equals 0. Or C equals negative E for future reference. Doing the X squareds, again, we don't have an X squared on the left-hand side. And going down the line over here, we have a 2a x squared. We have a b x squared. And we have a d. That is the most complicated equation so far, but we already know a is 1. So b plus d equals 2. Or negative 2. We can use that equation later if we can find b and d, b or d. X cubed terms. Again, still no x cubed on the left-hand side. Going down the line, we have a c, and that is it. So c equals 0. Remember this piece of information back here? That c equals negative e. Negative 0 is 0. So c and e are both 0. Which is very nice for us. And then the last thing we still need b and we still need d. Hopefully the x to the 4th will help find those. So let's find those x to the 4ths. We do have an x to the 4th on the left-hand side. That's 1. There's 1 x to the 4th. Then we have a. We know a is 1, but I'm going to write it as a for right now. And we know we also have a b x to the 4th. And those are all of our x to the 4th terms. This means that 1 equals 1 plus b, because a is 1, means b equals 0. It's great for us. And that actually tells us that d, coming back to this equation, we know b and we know a. 0 equals 2 times 1 plus 0 plus d. D equals negative 2. So we have all of our coefficients built up pretty quickly from just matching degrees. That means now, back when we looked at our partial fraction decomposition, if A is 1, we have 1 over x. B and C are both 0, so that fraction, that rational is just going to go away, plus negative 2x, E is 0 over x squared plus 1 squared. So integrating x to the 4th plus 1 over x times x squared plus 1 squared works out nicely to just be integrating this 1 over x plus negative 2x over x squared plus 1. Instead of going down and rewriting it, I will do that up here. Integrating of 1 over x plus dx plus the integral of negative 2x over x squared plus 1 dx. Actually walk through the u sub here that keeps being used. This is u equals x squared plus 1. There's a squared on this term from down here. Du equals 2x dx, meaning this second integral is the integral of negative 1 over u squared d. I walked through the negative 1 over u squared. I walked through 1 over x squared on the last video of reminding how that integral works. The first one becomes the natural log of x, absolute value of x. And the second one will become plus 1 over u plus c. And u is x squared plus 1. So there is our integral of x to the 4th plus 1 all over x times x squared plus 1 squared. Work through the partial fraction, and then the integral becomes really nice and easy. So there, with all those videos, is the process of partial fraction decomposition.